This is how you find the reflection coefficient using a Smith chart. So you have the Smith chart here. This is the Smith chart. So first thing you do is you plot the load impedance, then you draw the VSWR circle, then you use a compass to find the magnitude of the reflection coefficient, and then you draw a line in order to find the angle, because it's a complex number. So the real part is the magnitude, which is here, and the imaginary part is the angle. But you don't even really need to know that. So you just plot the impedance, draw the circle, draw a couple of lines, and you're done. So I'm doing this assuming that you know how to plot an impedance and find VSWR circle, which is in previous videos. So let's do this. We have the example is here. Find the reflection coefficient of this impedance, assuming a characteristic impedance of 50 ohms. So we normalize, the normalized impedance is going to be, what is that, 200 over 50 is 4, minus j, 50 over 50 is 1. 4 minus j1. So we plot 4 minus j1, then we draw the VSWR circle, and then we use our compass. I'll show you how to do that, and then we find the angle. Simple as that. 4 minus j1. So reflection coefficient of load impedance equals 200 minus j 50 ohms, characteristic impedance 50 ohms, like that. So 4 minus j1, 4 is here, minus j1, j1 is here, so we can, so this is the load impedance. So we've plotted the impedance, now we've VSWR circle. So I can do that. Trying to make it really dark so you can actually see it. So there's my VSWR circle. If I felt like it, I could find VSWR by looking where the circle crosses here, which is actually 4.25. But what I really want to do is find the reflection coefficient. So what I'm going to do is go down to the bottom where it says radially scaled parameters, and I look here. And you'll see, I'll show you what's here. It says reflection coefficient voltage. So the numbers that I'm looking for are these ones. And if you recall, I drew the VSWR circle. So while I have my compass this way, I'm going to put the pointy part right here, and I'm going to go like this. And I'm going to look right here. And if I do that, I will see that the magnitude of the reflection coefficient is 0.625. So then I can say magnitude is 0.625. That's the magnitude. And to find out what the angle is, I need a straight edge. So I'll make a straight edge, and I'm going to draw a straight line from the center of the chart out through this point. And I'm going to look right here. And if I look at that number, it says minus 2, 4, 6, 7, minus 7 degrees. Okay, minus 7 degrees. So then I can say the reflection coefficient is 0.625 with an angle of minus 7 degrees. Done. That is how you do it. So what you do is you plot the impedance, you draw the VSWR circle. While your compass is that size, you go down to radially scaled parameters, you make an arc, you read what the number is, that's the magnitude of the reflection coefficient, and then you draw a straight line through here, and you look at this number to help yourself remember which number to look, because you have 1, 2, 3, many different numbers to choose from. If you look on this side, it's the set of numbers that says angle of reflection coefficient in degrees. And that's how you find reflection coefficient using the Smith chart.